All right, so the question was, how do I do the stuff with kinetic energy and root mean square velocity? I'm assuming you read sections 5, 6, and 5, 7 in the book, so you would have seen all the stuff that goes with this. I'm just going to go through and show you how to do some of these problems. We use the formula to find the average kinetic energy of a gas, and that's going to be per mole, and you're going to see why in a second. 3/2 RT. Now that works for any gas at any Kelvin temperature. Assuming that we use the value for R, though, that has the energy units. And R in this case, 8.314 joules per mole Kelvin. A joule is an energy unit. It's equal to 1 kilogram meter squared per second squared. So it has mass and it has velocity squared inside of it. When we go through and do the calculations, the only thing we're really going to cancel then is the kelvins, and we're just going to end up with joules, energy units, when we go through and use this formula. So find the average kinetic energy of any gas at 200 degrees Celsius. Ke bar equals 3/2 times 8.314 joules per mole Kelvin times 473 Kelvin. We go through and do the math. And we get 5,899. And that's joules per mole. Only the kelvins cancel. If we want to put that in kilojoules, just divide by 1,000 or times 1 kilojoule over 1,000 joules. And it's 5.899 kilojoules per mole. They're all like that. You just pretty much have to go through and find the right temperature, and you're going to get then per mole value. As far as the root mean square velocity goes, the URMS is equal to the square root of 3 times R times T over that big fancy script M, and the whole thing's under the radical. That big fancy script M is the molar mass of the gas, but that's in kilograms. Molar mass in kilograms. Sorry, camera's adjusted a little bit. So if we're going to do something, we need to know what the formula for the gas is, and we have to know the temperature. So find for, I don't know, let's go with fluorine gas, F2, at 315 degrees Celsius. Fluorine, the molar mass is 19, so F2, molar mass is 38 grams per mole. But to use this, we have to put it in kilograms, which will end up then being 0.038 kilograms per mole. We then plug it into the formula, 315 Celsius is 588 Kelvin. So the URMS is 3 times 8.314 joules per mole Kelvin, and 588 over the 0.038 kilograms per mole. From a unit standpoint, kilograms cancel, moles cancel, and moles cancel. Or I'm sorry, Kelvin cancels, not kilograms. And we're left with joules over kilograms. If we do the math, we get 385,945. We have to take the square root of that. That gives us 621.2. So URMS equals 621.2. And the units that we have left are joules per kilogram. But if we look at joules again, we realize that's kilograms meters squared over seconds squared. And then there's a kilogram on the bottom from here. So those kilograms would cancel out. And we're left with meters per second squared under the radical, which then just gives us 621.2 meters per second. And that's clearly a velocity value. And that's pretty much how you do them.